All right, 3.6 sinusoidal function transformations. All right, so I want to begin with sine and cosine, the curves of sine and cosine. And so, what does sine start with? Sine starts where? At 0, and it starts going which way? Up. Now, where does sine reach its maximum at? Okay, the y value is 1, but the theta value or our input value is what? Pi over 2. All right, and so it reaches its maximum at pi over 2, and the value is 1 normally. Now, how long does it take to complete its cycle? What's the period of sine? 2 pi. All right, and so that's sine. That's kind of what I wanted to talk about there. Now, cosine, where does cosine start?
1.
At 1, and it starts going which way? Down. Okay, and so then how long does it take to complete its cycle? At 2 pi. And so it starts at its maximum at 0 at 1. All right, pretty good. All right, and so that will lead us in. Here we go.
All right, you ready?
I'm ready.
Previously in topics 3.4 to 3.5, we learned how to identify the midline, amplitude, and period from the graph of the graph of a sinusoidal function. Now we will learn how those properties affect the equations of sinusoidal functions. To do this, let's consider how the midline, amplitude, and period affect the graph of a sinusoidal function through the lens of transformations that we learned in Unit 1. The midline of a sinusoidal function is simply a vertical translation.
All right, so the midline is kind of our shift vertically. All right, and that happens outside of our function. That's going to add or subtract, and that shifts it vertically. All right, keep going.
The amplitude of a sinusoidal function is the vertical dilation.
All right, so this is what's going to be multiplying, and that's going to stretch horizontally. Or vertically, vertically.
The period of a sinusoidal function is the result of a horizontal dilation.
All right, beautiful. Okay. And so this is kind of doing what the opposite is, because now we're squishing horizontally. All right, keep going. You're doing great.
Given a function written as f of theta equals a sine b theta plus d, or k of theta equals a cosine b of theta plus d, the graphs of f and k will have the following transformations. Number 1, a vertical dilation by a factor of a.
All right, so the a represents our amplitude.
Number 2, a vertical translation of d units. D represents the midline of the graph.
All right, so that will shift it vertically. All right, number 3.
Number 3, a horizontal dilation by a factor of 1 over b. The period is given by p equals 2 pi over b.
All right, beautiful. And so a horizontal dilation is kind of what it does the opposite. Remember, when it affects the x, it does kind of the opposite of what you might think. All right, and so if you're multiplying, it's really dividing. It's really the reciprocal of that. Now, what's our normal period of sine and cosine like we just talked about? 2 pi. And so we're going to take that 2 pi and divide it by the coefficient of b here. All right, so let's move to example 1. All right, so in example 1, we need to solve for a, b, and d here. All right, and so I kind of like to go a little bit backwards here. I like to always start out with my midline. And so what would be the midline here? Y equals 3. All right, and so d, it shifted up 3. And so d ends up being 3 on that one. All right, and then amplitude, it kind of represents our a here. Now, amplitude is always what? Positive, remember? And so when we talk about this, a might not always be positive because it might be flipped, but my amplitude is always positive. So what's my amplitude on this one? 6. And so a is also 6. Now, what is this period? So what is the period of this function? How long did it take to complete its cycle? Pi. And so our normal period here is pi. Now, what's my normal period of my function for sine and cosine? 2 pi. And so I'm going to set 2 pi over b is equal to pi. And so how would I solve for b? I multiply by b and then divide by pi. And so b must equal what? 2. All right. And so this is the function like 6 sine of 2 theta and then plus 3. That's what that sinusoidal function would be. All right. So on example 2, we need to find an expression for f of theta. And so we need to solve for our a and our b and our d here. And so I always like to start out with my midline. And so what would be my midline here? Y equals 3. And so that solves for which one? The a, the b, or the d? The d. And so the d equals 3. And then let's go to amplitude. And so what's my amplitude here? 3. Okay, my gap between my max and my min from my midline is 3. And so my a would equal 3. Now, to solve for my b, we need to look at our period. And so what's the period of this function? Pi. My period is pi here. And so now what's my normal period of sine or cosine? 2 pi. And so I take 2 pi and I would divide it by b, which would be equal to pi. And so b is equal to what? 2. And so now my sinusoidal curve, so f of theta, would equal my 3 for my amplitude, or my a, and then sine of my b of 2 theta, and then plus my midline of 3 there. All right, and so that's my expression for sine. Now, why is that sine and not cosine? Because it starts basically at a 0, and then it starts moving what? Up. All right, and so that's why it's the sinusoidal curve and not a cosine curve, even though cosine curve is a sinusoidal curve because it's just a shift. All right, so let's look at this example now. So in this example, we just need to figure out what the period and our amplitude is. So just like before. And so how long did it take to complete this cycle? Pi. It took pi. All right, so it took pi amount to complete its cycle. So my period is pi, but what's my amplitude on this one? 2. And so it goes up 2. And so that one is A. All right, pretty good? All right. All right, Miranda's going to read example 4.
Example 4. The trigonometric function k has a maximum point at 0, 6. After this maximum, the next minimum occurs at the point pi over 2 and negative 4. Which of the following could be an expression for k of x?
All right, so I'm going to kind of sketch this little graph here, okay? And so it starts out at 0, 6, all right, which would be its maximum. And then at pi over 4, it goes down to what? Or pi over 2, it goes down to negative 4, right? And so how long of the period did it go? It went half of it. Just like before, it went half of it. And so it needs to go another pi over 2 to get back up to 6. Agreed? And so how far is my period then? Pi. All right. And so my period here is pi. Do we see how we did that part? All right. So my period is pi. Now, we could solve for b right now. Yeah, let's solve for b. What's my normal period? 2 pi. And I'm going to divide it by b, which is equal to pi in this case. So what's my b? 2. All right. So my b is 2. Now, if I have a maximum of 6 and a minimum of negative 4, what would be its midline? Its midline would be y equals 1. All right, so my midline is y equals 1, which tells us our d is what? 1. Now, what's its amplitude? 5. All right, my amplitude would be my distance between my midline and my max or my min. And so my d here, oh, sorry, not my d, but my a is what? 5. All right, and so now I'd end up having 5, and then sine or cosine. Which one is this one going to be? Now, you could look at your answer choices. It's going to be cosine, right? But how do we know, just looking at the graph, how do we know this is a cosine function? Because it starts at its maximum, and then it starts going which way? Down. All right, and so it starts going down, and so this is good. This is going to be a cosine of what's my b? 2, and then x or theta, I guess, and then plus what's my d? What's my midline? 1. And so that would be our function for k of x. All right. I think, and so which one does it go up with? D. All right. I think a good distractor would be like 5 sine of 2x plus 1. Now, would it have the same period and the same midline and the same amplitude? Would this have the same thing going on there? Yes, it would. All right. However, what's the difference between it? Where would sine start? Sine would start at its what? Its midline. And so this would start where? At 1 in this case. All right, because it would start at its midline and then start going up. And this one started up and it went which way? Down. All right, so I think this would be a great distractor on an actual AP exam. All right, let's keep 3 moving. So now on this one, we got 3 sine of 2x minus 1. All right, so let's break it down. And so what's my amplitude here? All right, so my amplitude is 3. And so then what's my midline? Y equals negative 1. All right, and so my amplitude, it should be 3. And then my midline should be what? Y equals negative 1. Now let's find our period. And so what's my normal period of sine? 2 pi. But I divide it by my coefficient of x, so my b. And so what's my b here? 2. And so what's my period now? Pi. All right. And so let's look at A. And so does this one have an amplitude of 3? Does A have an amplitude of 3? No, it has an amplitude of what? 2. So is that one it? No. And so A, that gone. All right, let's look at B now. And so does that have an amplitude of 3? Yeah, sure. And then does it have a midline of negative 1? Yeah, sure does. But does it have a period of pi? No. How long did it take to complete that one? 2 pi. And so that one had a period of 2 pi. And so is it B? No. Let's look at C now. So does it have an amplitude of 3? Yeah. Does it have a midline of negative 1? Does it have a period of pi? Yeah. So that one must be it. All right.
Phase shift of a sinusoidal function. A horizontal translation of a sinusoidal function is called a phase shift. The graph of g of x equals sine of x plus c is a phase shift of the graph of f of x equals sine of x by minus c units, negative c units.
Yep.
The same results can be applied to the cosine function.
All right. So again, if you add or subtract inside a function, so you're messing with the x, it does the opposite of what you might think, remember? And so if you add something inside the function, which way does it move? Left. All right. And if you subtract something, which way does it move? Right. And this has a special name with sinusoidal curves, and it's called a phase shift. All right. But literally, it's just a horizontal translation. It's the same thing. All right. So you're going to get a form of a sine or a cosine like this. You're going to have your a sine of b times the quantity x plus c and then plus d. In example 6, we need to figure out which trig function goes with the graph. All right, and so let's just look at the graph. Okay, so what's my midline? So what's my d? Let's kind of just break it down a little bit. What's my d? Negative 1. All right, my midline here is negative 1, or y equals negative 1. So my d is negative 1. And then what's my amplitude? My amplitude is 3. All right, so my amplitude is 3. And then let's look at its period. Well, what's my period here? 2 pi, right? And so I need to solve for b. Well, what's my normal period? 2 pi. And then I divide it by b, which is equal to 2 pi. So what does b equal? 1. So b is equal to 1. And so the c, the horizontal translation or the phase shift, is probably what's going to happen. And so let's look at our answer choices. Does A have an amplitude of 3? It does. Does B have an amplitude of 3? It actually does. All right, because amplitude is always what? Positive. What does the negative do out front? What does this actually do? It flips it. All right, it flips it over the x-axis. Remember, if you make it negative out front, it flips it over the x-axis. But the amplitude is still 3. is this amplitude's 3? Yeah, how about this one?
Yeah.
Yeah. How about my midline being -1 every single time? Is that still the same case? Yeah. How about my period being 2 pi? Let's say my b is 1. Do I have a coefficient of 1 for all of my x values? Yes. So it's like, how in the world do we narrow it down? There's lots of different ways you can go about it. However, this is the way I'm going to go. I would pick a point and test it. All right. And so a lot of the times I like to substitute in 0. However, you could substitute in anything, like pi would be a decent choice. All right. And so if you substitute in pi, what should you get out of one of them? You should get out 2 if you were to substitute in pi. If you substitute in 0, what should we get out of one of them? -4. All right. And so that's the way that I'm going to show. So we're going to substitute in pi. All right, so we're going to substitute in pi, and what do we want our result to be? We want it to be 2. All right, so let's look at A. And so if we substitute in pi, well, what's cosine of pi? -1. -1. And so now -1 times 3 is what? -3. -3 minus 1 is? -4. Is that 2? No. So is it A? No. All right, let's look at B. So I'm going to substitute in pi again, because that's the one we're choosing. And so if I substitute in pi, what do I get? Pi minus pi, which is 0. So then I have cosine of 0. So what is cosine of 0? 0. Oh, no. Cosine of 0 is what? 1. And so now I have -3 times 1, which is -3, minus 1, which is -4. Is that 2? No, so it's not that one. All right, let's look at C now. So I'm going to substitute in pi. And so what is pi plus pi over 2? 3 pi over 2, exactly. So what is the sine of 3 pi over 2? It goes down, -1. And so now I have -1 times 3, which is -3, minus 1, which is -4. So is it 2? No, so it better be this next one. All right, let's try it. So if we substitute in pi, I take pi minus 3 pi over 2. So what's pi minus 3 pi over 2?
Pi over 2.
Negative pi over 2. So this is the same thing as saying sine of negative pi over 2. Now, is negative pi over 2 on my unit circle? No. So let's deal with it. So remember, really it goes backwards, yes? Okay, so really negative pi over 2 goes to which one? 3 pi over 2. All right, that's one way to think about it. That's really what happens. The way that I think about negative values in my head is I actually think of where pi over 2 is, and then I flip it over the x-axis. And so pi over 2 is right here, and then if you flip it over the x-axis, you're at 3 pi over 2. And so if you have like -5 pi over 6, really it goes backwards to 7 pi over 6, but really I think of 5 pi over 6 and then I flip it. And so then you're at 7 pi over 6. That's how I deal with negative radian measures. All right? But really you can add 2 pi to it, you can go backwards if you want, or you can flip it over the x-axis. All right? I personally like to flip. All right? So sine of negative pi over 2 is really sine of 3 pi over 2. So what is sine of 3 pi over 2? -1. And so then I have -1 times -3, which is 3. 3 minus 1 is 2. So is that the one we want? Yes. All right. And so there we go. On this one, again, what's its midline? Let's talk about its midline first. 1. All right. So we got y equals 1. And so my d is equal to 1. And so then let's talk about its amplitude. And so what's my amplitude here? 2. And so a is equal to 2. And then let's talk about my period. Well, what's my period? How long did it take to complete its cycle? Pi. It took pi. And so to solve for b, we take 2 pi over b, which is equal to pi. And so b is equal to 2. Now, let's look at our answer choices and see if we can narrow anything down. Could we narrow anything down at all? Nothing. Nothing. All right. And so this is where I would suggest kind of picking a point and going with it. All right. And so really I would kind of pick like 0, -1, or pi over 2, 3, or pi -1, something like that. All right, which one do you want? I really don't care.
0.
0? Let's do 0 then. All right, so we substitute in 0. So if I substitute in 0, I got 0 minus pi over 4, which is negative pi over 4, right? So really, and then I multiply it by 2. So negative pi over 4 times 2 is negative 2 pi over 4, which is negative what? Pi over 2. And so negative pi over 2 is really where? 3 pi over 2. So what's the cosine at 3 pi over 2? 0. All right. And so then 0 plus 1 is 1. Is this what I want? No, I want negative 1. So that's not one. That's not the right one. So let's do it again. So we substitute in 0. And so 0 minus pi is negative pi. Negative pi times 2 is negative 2 pi. So where is negative 2 pi the same as 2 pi or 0? Really? All right, so what's cosine of 0 or 2 pi? 1. And so now I have 1 times 2, which is how much? 2. 2 plus 1 is 3. Is that the one I want? All right, and so now let's look at this next one. So now let's substitute in 0 again. So 0 minus pi over 4 is negative pi over 4, and then multiply by 2. What do we get? Negative pi over 2, which is the same thing as what? 3 pi over 2. So what is the sign of 3 pi over 2? Negative 1. So negative 1 times 2 is? Negative 2 plus 1 is? Negative 1. Is that what we want? That's the one. All right. All right. On this one, it gives us some ordered pairs. So this F is 216. And this G is 511. I'm putting up here so I can see them better. This J is 86. K is 1111. And then P is 1416. All right, cool. All right. And so on this, it says, hey, H of T can be written as A sine of B times T plus C plus D. And we're going to find A, B, C, and D. All right. A, B, and D, pretty easy. C, kind of a little bit of a pain, but we're good. All right. So let's break it down. And so A represents our what? Our amplitude. Well, what's my amplitude on this one? 11 to 16. 5. All right, so my amplitude is 5. Pretty good there? All right, cool. And so let's go D here. So let's go to our midline. And so what's my midline? Y equals 11. And so D is 11. All right. Now let's do B first. All right, because we almost have to. Actually, we do have to. And so let's solve for B. And so how long what's my period on this one? 12. My period is 12. It goes from 2 to 14. So my period is 12, right? Well, what's my normal period of sine? 2 pi. And so I'm going to take 2 pi divided by B is equal to 12. And so what does B equal? Pi over 6. Exactly. Good. And so B is equal to this pi over 6. And so right now I end up having my A is what? 5, and then sine of pi over 6 times T plus C, and then plus 11. And so this is what we have going on right now. All right. Now, there's multiple ways to do this, and this is the way I'm going to show you. Okay, so this is the easiest method I think that we have. A normal sinusoidal function starts at 0, right? Yes? And then it goes which way? Up. And where did it reach its maximum? At what? At pi over 2. Do you remember that? And so a normal sinusoidal function reaches its maximum at what? Pi over 2. Okay? So what we're going to do here is we're going to set this inside part equal to pi over 2. Because it would normally reach its maximum at what? Pi over 2. And so I'm going to set pi over 2 equal to pi over 6 times my t value. Now, what t value did it reach its maximum at? In this case was what? 2. And I'm solving for c. So I'm setting pi over 2 equal to pi over 6 times the quantity 2 plus c. All right? And so now I need to solve for c. Well, what's happening? So pi over 6 and this quantity 2 plus c are being multiplied, right? And so multiplication is the same thing as the inverse of multiplication is what? Division, which is the same thing as multiplying by its what? Its reciprocal. And so I'm going to multiply both sides, everything, by 6 over pi. All right? And so 6 times pi is what? 6 pi. Pi times 2 is 2 pi. So 6 pi over 2 pi is what? Nope, just 3. The pi's cancel. All right? And so then this pi over 6 times 6 over pi goes to 1. And so now I'm just left with 3 is equal to 2 plus c. All right? And so what does c equal? C equals 1. And so now that I have that, I can just back substitute it, or I guess in this case it just says find the value. So c is equal to 1. And so h of t would equal 5 sine of pi over 6 times t plus 1 plus 11.